To determine a motor's compatibility with a variable frequency drive, or VFD, when the specifications are not readily available, there are several avenues to explore. Firstly, examine the motor nameplate. The motor nameplate typically provides crucial information such as the motor's voltage, current, power, and speed. This data is essential for assessing compatibility with the VFD output voltage and frequency capabilities. Ensure that the motor's voltage rating aligns with the VFD output voltage range. Similarly, the motor's rated frequency should be compatible with the VFD adjustable frequency range. Secondly, consult the motor datasheet. The motor datasheet offers a more in-depth overview of the motor's electrical and mechanical characteristics. It provides detailed specifications that are vital for ensuring the motor can effectively handle the VFD output. Pay close attention to parameters such as the motor's insulation class, thermal overload capacity, and torque characteristics. These factors directly impact the motor's ability to operate reliably under the variable frequency and voltage conditions imposed by the VFD. Thirdly, explore the VFD manufacturer's website. VFD manufacturers often maintain lists of compatible motors on their websites. These lists are a valuable resource for identifying motors that have been tested and verified to work seamlessly with their VFD. While not exhaustive, these lists can provide a helpful starting point for your compatibility assessment. It is important to note that compatibility should always be verified through other means as well. Fourthly, seek assistance from a motor application engineer. Motor application engineers possess specialized knowledge and experience in motor VFD integration. They can provide expert guidance in determining motor VFD compatibility and assist in selecting the most appropriate VFD for a given motor. An application engineer can assess the specific requirements of the application, taking into account factors such as load characteristics, operating environment, and performance expectations. They can then analyze the motor's specifications and compare them to the VFD capabilities, ensuring a compatible and optimized system. When evaluating motor VFD compatibility, several key considerations must be taken into account. The voltage compatibility is paramount. The motor's rated voltage must match the VFD output voltage capabilities. Operating a motor at a voltage significantly higher or lower than its rated voltage can lead to damage or performance degradation. The frequency compatibility is equally important. The VFD must be capable of providing the range of frequencies required by the motor for the intended application. Operating a motor at frequencies outside its design range can result in overheating, reduced torque, or mechanical damage. The current compatibility should be assessed. The VFD must be able to supply sufficient current to meet the motor's demands, particularly during starting and acceleration. Overloading the VFD can lead to tripping or damage to the VFD components. The motor's insulation class should be adequate for the VFD output voltage waveform. VFD can generate voltage spikes and harmonics that can stress the motor's insulation. Selecting a motor with a higher insulation class can help mitigate this risk. The motor's thermal overload capacity should be sufficient to handle the increased heating that can occur when operating with a VFD. VFD can introduce harmonic currents that increase motor losses and lead to higher operating temperatures. The motor's cooling system should be adequate to dissipate this additional heat. The motor's torque characteristics should be compatible with the application's requirements. VFD can alter the motor's torque speed curve, so it is essential to ensure that the motor can provide sufficient torque at all operating speeds. When selecting a VFD for a motor, it is crucial to consider the VFD features and capabilities. The VFD should have appropriate control modes for the application, such as volts per hertz control, sensorless vector control, or closed-loop vector control. The VFD should have adequate protection features, such as overcurrent protection, overvoltage protection, and undervoltage protection. The VFD should have appropriate communication interfaces for integration with other control systems. The VFD should be sized appropriately for the motor's horsepower rating. Using a VFD that is too small can lead to tripping or damage, while using a VFD that is too large can be inefficient and costly. In summary, Determining motor VFD compatibility requires a thorough assessment of the motor's nameplate data, datasheet specifications, and the VFD manufacturer's recommendations. Consulting with a motor application engineer can provide valuable expertise and ensure a reliable and optimized system. By carefully considering voltage, frequency, current, insulation, thermal overload capacity, and torque characteristics, you can select a compatible motor VFD combination that meets the demands of the application and ensures long-term performance.